So the triangular element. Here we are going to analyze the triangular element. So in child representation we have perfect triangle. In parent representation we can have some boundary, curved boundary in the triangular element. So we have some intermediate point connecting all the edges, so that this one is the first area, second area, third area. The nodes are 1, 2, 3. The point P representing with the shape function of L1, L2, L3. Here the shape function are denoted as L1, L2, L3. L1 is the ratio of area 1 divided by the total area. That is area 1 representing area of P23. That is area of P23 triangle divided by the total area. That is area of 1, 2, 3. So L2 area of 2 by total area, which is a area of 1 P3 divided by area of 1, 2, 3. So L3 is the area between third portion to the total area. So which is equal to area of area of P12, because this is the third portion, so it is P12 is the triangle divided by area of 1, 2, 3. So our assumption, the summation of all shape function L3, L2, L1 which is equal to 1. The displacement in x direction is represented as L1 x1 plus L2 x2 plus L3 x3. Y is L1 y1 plus L2 y2 plus L3 y3. So now representing with the shape function, representing here in terms of shape function, it is xy, which is equal to n1 0, n2 0, n3 0, 0 n1, 0 n2, 0 n3 as in the case of constant strain triangle, and n1 x1 y1 x2 y2 x3 y3 is the coordinate, where n1 is equal to L1, n2 equal to L2, n3 equal to L3. So in this derivation we are having the shape function L1, L2, L3 instead of n1, n2, n3. So now I am going to calculate the shape function for n1. So here I am going to represent the parental element with coordinates. So here it is 1, 0, 0. The second node, first node, the first element is 1. Second node, the second element is 1. Third node, the third element is 1. In between, fourth node, the midpoint between this, midpoint of the first element, midpoint of the second element, third element is 0, third coordinate is 0. So half, 0. Third coordinate is 0, and we consider the midpoint of first two coordinates. 4, this is 5. Fifth coordinate, you see the third coordinate is there, second coordinate is there, first coordinate is 0. So first coordinate is 0, second coordinate is half, third coordinate is half. And the sixth coordinate, half the first coordinate, 0 the second coordinate, half is the third coordinate. So now I am going to write the equation for n1, which is equal to scale factor. So you consider the equation. Here it is having small change. Equation 253 multiplying the equation 46. Equation 46. You have to multiply the equation 253 with the equation of the intermediate points 4 and 6. Equation 4 and 6. So shear force, scale factor. Scale factor. Equation 253 is the first coordinate is 0, the second coordinate is also varying. The first coordinate is 0, second coordinate is varying, third coordinate is varying. So the first coordinate is L1, L1 is equal to 0. So the equation is simply L1. And equation 4, 6, equation for the line 4, 6, having the common coordinate of L1 is equal to half. L1 is equal to half. So 2L1 minus 1 equal to 0. So this is the equation. If you cross multiply this 2L1 minus 1 equal to 0. So 2L1 minus 1, second equation, N1. We can find the value of N1 equal to 1 with the scale factor, where L1 is also 1. Because at the node 1, L1 equal to 1, all other two values are 0. So 1, 2 minus 1. So scale factor, which is equal to 1. So N1 equal to simply L1, 2L1 minus 1. Similarly, all other scale factors are 1 and remaining shape factors. Next one for N2. For the node 2, we should consider the equation 361. Scale factor, you need not again calculate, you put simply 1. Equation 361 multiplying the equation 5 and 4. Multiplying the equation 5 and 4. 361, 5 and 4. So equation 361, what is the common factor? 361, the common factor is midpoint 0, which is L2. Because the L2 is 0, so the equation is L2. And the equation 5 to 4, the common factor is Y, that is the second coordinate, half. So 2L2 minus 1, because here L2 equal to half. If you cross multiplication this 2L2 minus 1, which is equal to 0, is this directly the equation. So 2L2 minus 1. So N2 we can finalize this equation, L2 2L2 minus 1. So this is equation number 2. Here this is equation number 1. So next N3 shape function N3 equal to the third node, scale factor equation 241 multiplying the equation with 5 and 6, equation 5 and 6. So it is N3 equal to scale factor equation 241 is having common thing of L3, and equation 5, 6 is having common factor of half in L3. So it is L3 equal to half L3 equal to half. So it is 2L3 minus 1. 2L3 minus 1 is the third equation. So the scale factor is 1. So it is L3, 2L3 minus 1 is the shape function. The next point, N4. So you can try to draw the point 1, 2, 3, 4, 5, 6. So for writing the equation for 4, n4, we have to take equation 3, 5, 2 and equation 163. 3, 5, 2, 163. So 1, 0, 0, 0, 1, 0, 0, 0, 1. So midpoint, so half, half, 0, here 0, half, half, this point, half, 0, half. So n4 shape function scale factor into equation, it is a midpoint, so we have to consider both the boundaries. Equation 352, equation 361, equation 361. Scale factor, equation 352 is having common value of L1 equal to 0. So you can write L1 multiply by equation 361 is having common value of L2. So L2, N4. So consider N4 is equal to 1 at L1 is equal to the coordinate of 4. L1 equal to half, L2 equal to half. So 1 which is equal to scale factor into half into half. So scale factor for this equation is 4. So N4 is equal to 4 into L1, L2. Similarly, N5 is equal to, it is influenced with L2, L3. So it is 4L2, L3. N6 is equal to, it is influenced by L1 and L3. So it is 4L1 and L3. So this is the remaining equations 4, 5 and 6. So you can write the displacement equation from n1 0, n2 0, n3 0, n4 0, n5 0, n6 0, 0, n1 0, n2 0, n3 0, n4 0, n5 0, n6 with the coordinates of x1 to y6, x1 to y6. From this we can calculate the displacement. So this is what about the triangular element of 6-noded triangular element. This derivation is about the 6-noded triangular element with natural coordinates.